Hello, I'm Mahendra Shetty, founder, Yes Mahindra Academy. Before starting this session, we will have an exercise. Here, we have to find out the number of variables in a given equation and decide whether the equation is linear or not. So, in given second equation, there are two variables, x and y, but the degree of that variable is -1. Therefore, this equation is not linear equation. In equation 3, there are two variables, and as the degree of that variables is -1, therefore this equation is not also a linear equation. And equation number 4, again there are two variables x and y having degree -1, therefore this equation is not also a linear equation. So here all the equations are not linear equations. So here is one question: can we convert the equations into linear equations? The answer is yes, we can. We can convert this equation in a linear equations, and this method is known as reduction of equations to a pair of linear equations in two variables. Now, how this process will work, we will see in detail. Here we have two equations. Equation number 1 as 4 upon x plus 5 upon y is equal to 7, and equation second is 3 upon x plus 4 upon y is equal to 5. Now, after observation, we can rewrite this equation like this: 4 into 1 upon x plus 5 into 1 upon y is equal to 7, and 3 into 1 upon x plus 4 into 1 upon y is equal to 5. So, if we consider the variable as 1 upon x and 1 upon y in equation 1 and 1 upon x and 1 upon y in equation 2, here we can easily substitute these variables with another variables like 1 upon x as m and 1 upon y as n. Therefore, this equation 1 will become 4m plus 5n is equal to 7, and equation number 2 will become 3m plus 4n is equal to 5. Now, here the variable is m and second variable is n. Similarly, same variables are available in equation number 2, and the degree of both variables is 1. Therefore, these two equations are linear equations in two variables. And after considering these equations as simultaneous linear equations in two variables, we can find out the solution of these equations. So, moving towards the solution of these equations, after reducing them in a different linear equations in two variables, we will get equation number 1 as 4m plus 5n is equal to 7. This will be equation number 1, and 3m plus 4n is equal to 5. This will be equation number 2. So, we will find out the solution of this equation by elimination method. So, therefore, we will multiply equation number 1 with 3, that is the coefficient of variable m from equation number 2, and equation 2 by 4, the coefficient of variable m from equation number 1. So the equations will be reduced to 12m plus 15n is equal to 21. This new equation we will designate it as equation number 3, and equation number 4 will be 12m plus 16n is equal to 20, and we will designate it as equation number 4. Now we will subtract equation number 4 from equation number 3. So therefore the values will be 12 minus 12, 0, and variable will be m. So this value will be 0, and 15n minus 16n, the value will be minus n, and 21 minus 20 will be 1. So therefore the value of n will be minus 1. Now we will substitute the value of variable n in equation number 1, and we will get the value as 4m plus 5 into the value of n we will substitute as minus 1 is equal to 7. So 4m minus 5 is equal to 7, and 4m is equal to 7 plus 5, that is 12, and the value of m will be 12 divided by 4 is equal to 3. Now here we have got the values of replaced variable m as 3 and n as minus 1. Now we will substitute these values in considered variable, like we have considered m as 1 upon x and n as 1 upon y. So the value of x here will be 1 upon m, and the value of y will be 1 upon n. So the value of x will be 1 upon m, means 1 upon 3, and the value of y will be 1 upon n, means 1 upon minus 1, and that will be minus 1. So the solution for the simultaneous linear equation will be x and y 1 upon 3 and minus 1. So in this way we can convert the non-linear equations in linear equations by reducing them. Now we will see another example based on same process. So here we have two equations: 10 upon x plus y plus 2 upon x minus y is equal to 0, and 15 upon x plus y minus 5 upon x minus y is equal to minus 2. Now here we can write the first equation as 10 into 1 upon x plus y, 2 into 1 upon x minus y is equal to 4, and here 15 into 1 upon x plus y minus 5 into 1 upon x minus y is equal to minus 2. So now we can substitute the value of 1 upon x plus y and the value of 1 upon x minus y as m is equal to 1 upon x plus y, and n is equal to 1 upon x minus y. So we can substitute these values and write the equations like this: 10m plus 2n is equal to 4, and 15m minus 5n is equal to minus 2. This will be our equation number 1 and equation number 2. Here we will multiply equation number 1 with 5, the variable coefficient of variable n, and equation number 2 by 2, the coefficient of variable n. Then this equation will reduce to 50m plus 10n is equal to 20, equation number 3, and 30m minus 10n is equal to minus 4, equation number 4. So after adding equation number 3 and 4, we will get the result as 50 plus 30 will be 80m, 10n minus 10n will be 0, and 20 minus 4 will be 16. So the value of m will be 16 upon 80, that is 1 upon 5. Now we will substitute this value of m in equation number 3, and we will get 50 into the value of m will be 1 upon 5 plus 10n is equal to 20. So here the equation will be 10n is equal to 20 minus 10, and the value of n will be 10 upon 10, that will be equal to 1. So here we have got the values of m as 1 upon 5 and the value of n as 1. So now we will substitute these values like we have got m is equal to 1 upon 5 and n is equal to 1. So we have assumed m as 1 upon x plus y, okay, and the value of n as 1 upon x minus y. So here the value of x plus y will be, the value of x plus y will be 5, and here the value of x minus y will be 1. So again we have to solve this equation, equation number 5 and equation number 6, as simultaneous linear equation, and the addition of which will result as 2x is equal to 6, where x will be 6 upon 3, 6 upon 2, that is 3, and the value of y will be, after substituting in equation number 6, 3 minus y is equal to 1, minus y is equal to 1 minus 3 minus 2, and y is equal to 2. So here we have got the solution of these equations as x and y is equal to 3 and 2. So in this way we can solve these equations reducible to a pair of linear equations in two variables. In this session, we have learned reduced equations which are reducible to a pair of linear equations in two variables. After reducing, solve them by different methods. Thank you. We'll meet soon with other video on new topic. Thank you.